Hello. This video is for IXL Activity 7.E.3 titled Multiplying Decimals. Its three-character code is Tango Charlie Uniform, TCU. No, that's not Texas Christian University. It's just the three-digit code or the three-character code for this particular IXL. So the first one says use the grid to fill the missing numbers. So I'm going to talk about this grid for a moment, and before I do, I'm going to put it on a smaller scale so maybe we can understand it a little better. So I'm going to go ahead and pull up my camera here, and what I want to share with you is I have here a 3x5 index card here, right? So I'm going to take this 3x5 card and I'm going to first separate it into fourths. So I've already pre-folded it so that I can see the lines, but I'm going to go ahead and highlight those lines so that you can see the fourths. So I'll put a line through there, and through there, and through there. And so now you can see where I've highlighted it into fourths. There's 4 equal sections or 4 columns there, right? Now, the multiplication problem that we're going to do is, let's do 3/4 times, and then I'm going to go ahead and do, so I've got the 3/4 part, right? So we're going to do 3/4. Let the camera focus a little bit. Let back up a little bit. So I'm going to do 3/4. So on this, I'm going to represent, I'm going to do 3/4. But also, the question is, what am I going to multiply by the other side? And so I'm going to do the other one. You might be able to see it already. I'm going to do that into thirds. So let me go ahead and do those lines there into thirds. And you might be saying, well, I thought we were doing decimals, and you seem to be doing fractions, right? So I've got fourths going across this way, and now I got fourths going up and down, right? 1, 2, 3, 4. So I've separated this way into fourths, and then this way I've got separated into thirds. And I'm going to go ahead and multiply 3/4 by 1/3 for this problem. Now you might be saying those are fractions, but in all actuality, they're also decimals. They have decimal equivalents. In this case, the 3/4 is equal to 0.75. And we're going to be multiplying that, and the 2/3 or 1/3 is equal to 0.3 repeating. So I'm going to put a line over that. So I could divide those, or I could simplify those. Silly me, divide. I could simplify these into decimal equivalents. So what I'm going to do now is I'm going to show you using the grid here that looks very much like the grid on the IXL activity. So first I need to represent 3/4. So I'm going to go ahead and 3/4. I'm going to go ahead and shade them with lines going from diagonal lines. So 1, 2, 3. I got 2 of them just about there. So you can see that I have shaded 3 of the 4 equal sections there. So this is representing 3/4. Here's 1, 2, 3 of the fourths. Now I'm going to shade the 1/3, and I'm going to shade that going the other way. So I'll go ahead and shade 1/3 going that way. And now you can see that of the sections here, actually, I should have gone and shaded the whole thing there. There you go. So out of the 3 equal sections, 1, 2, 3, I've shaded right here, I've shaded one of them to represent 1/3. And remember, going the other way, I had shaded 1, 2, 3 of the fourths going across. So now let's count the number of boxes that are shaded, right? 1, 2, 3, and that's going to be the numerator. So that would be 3. So I'm making a fraction on the back there. So 3 of them have shading going both ways. And then the next question is, how many boxes are there altogether? Well, I have 4 across the top, 3 down the side, so there would be 12 altogether. So that would be 3/12. Now, there might be some out there saying, but 3/12 will simplify. And it will. It's simplified to, that's equal to 1/4. So you can see there that 3/12 is equal to 1/4. And I can show that here because if you think about it, if I had some scissors here, and unfortunately I don't, let's see if I could actually do that. So if I take 3/4, yeah, this will work out really nice. If I go ahead and take and rip out that shaded section there, all right, here is my solution area here. There's 3/4 right there. Now I can get 3 boxes here that weren't part of the solution. And then I could also have another couple sets of 3 that were not part of the solution. So here I've got 1, 2, 3 sets of 3 that were not part of the solution. And then I got the one set here that was our solution. So it was 3/12, right? 3 squares here, and 3, 6, 9, 3 more is 12. 3 of them were shaded, so 3/12 would be the solution. But that simplifies to 1/4 because there are 4 sets of 3, but only one of them was part of the solution, so 3/12 is equal to 1/4. And 1/4 is a decimal. 1/4 is a decimal, is equal to 0.25. Okay? So how does this all relate to what we were looking at on the example there? Get my pen back here. And looking at this grid, how does that all relate to this grid? Well, on the first one, we have, it says fill in the missing number. So let's, without even really thinking about this missing number down here, let's talk about the grid. So we have it divided into 10 equal spaces this way. And there are 10 equal spaces also going this way. You can pause them and count them up if you want. For the sake of time, I'm not going to actually count them all, but we do have 10 going in each direction. So we realize that it's 10 in each direction, and going in this direction, going across, out of these 10 here, we have 2 of them. So we have 2/10, or if we write that as a decimal, it's going to be 0.2. So we have 2/10 right here that are shaded. So this is going to be 0.2. And then across here, we have 1 of them. So across here, we have 1 out of 10 shaded, and this is equal to 0.1. So we have, put a 0 there in front of that. Here we have 0.1. And then if you count this, well, 10 times 10, right? 10 times 10 equals 100. So there must be 100 squares in here altogether. How many of them intersect in that? So we got the purple ones here, the pink ones this way, and the intersecting ones is 1, 2, 2 what? 2 out of 100, which is equal to 0.2, because that's the hundredths place. So that's 2 100ths. So with that said, we end up with, we see here that 0.2 times 0.1 equals 0.02. Yeah. And so what are we missing? There's the 0.2 right there. There's our solution right there. There's the 2 100ths that we see shaded right there. So that's the 0.2. What was it being multiplied by? The 0.1. All right. So hopefully the demonstration with the 3x5 card and along with this grid here will help you understand the concept of using a grid to explain multiplication of decimals. On the next one here, we have 0.3 times something equals 0.09. Well, we see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 of the 100. So 9 of 100, which is equal to 0.09. It's in the hundredths place, so we read that as 9 100ths. This is our answer right here, right? So we look along the side, we see that 3 out of 10, which is equal to 0.3 over here. And how many do we have here? Well, it looks like 0.3 here too, right? 3/10 as well. So we would need to type in 0.3. So 0.3 times 0.3 equals 0.09. And then we leave the grid. So that's your first one starting off will have the grid, and then we'll go over to without the grid. So on this one here, once we don't have the grid, many times we just refer to the standard algorithm to where we go ahead and multiply these together. So we pretend the decimals aren't there. So let's go ahead and I'm going to go ahead and write it 0.4 times 0.9, right? And we would do 4 times 9 times 4 is 36. Now we see that we have one number after the decimal here to the right of the decimal, and one digit to the right of the decimal here, and add these together. 1 plus 1 is 2. So we need to move the decimal over 2 places. Well, if the decimal were here in 36, we'd have to move it over 2 places, and we'd end up here for 0.36. 0.36. Now, I'm well aware that many students will use a calculator on this. If you use a calculator, I suppose that's fine. However, make sure that you understand how to use this algorithm here. So 9 times 6. Well, 9 times 6 is 54. But I have one decimal, one value to the right of the decimal here, and one value to the right, or one digit to the right of the decimal here. 1 plus 1, remember we're adding these, is 2. So we want to move the decimal over 2 places, so we're going to actually end up with 0.54. On the next one here, let's go ahead and I'm going to rewrite this 5.52 and what is it, 0.9. Now notice that the decimals are not lined up like we normally do with addition and subtraction, because you don't have to line them up with addition and subtraction. I'm trying to fix that 9, but just seem to keep messing it up. So we don't line them up here. We just treat them like they're not even there at first. So just like we would do 552 times 9, we're going to do the same here. 9 times 2 is 18. We're going to carry the 1. 9 times 5 is 45. Add 1 more, 46. Carry the 4. And 9 times 5 is 45. Plus 4 more is 49. Now, here we have 2 digits to the right of the decimal. Here we have 1. Let's add these together to get 3. So let's move the decimal over 3 spaces. 1, 2, 3. We're going to end up with 4.968. And that would be our answer on this one. 81 times, see, I'm already thinking of it, 81 times 4. 0.81 times 0.4. And I'm just going to treat it like the decimals aren't even there. And I'm going to write this as 0.4 there. Good. And 4 times 1 is 4. 4 times 8 is 32. Now I have 2 to the right of the decimal and 1 to the right of the decimal. 2 plus 1 is 3. Let's move that decimal over 3 spaces. And so that's where it would belong. So I would 0.324. On the next one, 33.3 or 3.3. See, I'm already thinking of it as 33. It's just a habit right away. I think 33 times 78, but I need to throw my decimals in there so I don't forget about them later on. 8 times 3 is 24. Carry the 2. Again, 8 times 3 is 24. Add 2 more is 26. 7 times 3 is 21. Carry the 2. And 7 times 3 is 21 again. Plus 2 is 23. Now we need to add these, right? Place holding 0. End up with 4, 7, 5, 2. 1 decimal. 1 to the right of the decimal, 1 to the right of the decimal. 1 plus 1 is 2. So I'll move that decimal over 2 places. It's going to go right here. So 25.74 is my final answer. Here I have 0.4 times 37.11. Now, notice I've been writing the first digit first up here. I put that at the top, and then I did that one. But instead of having, let's look how silly that would look. Let's have, if we did 0.4 times 37.11, it would just seem kind of awkward and strange. So let's do the one with the most digits up at the top. And then the one with fewer digits, such as 0.4 at the bottom. Now this seems to work a little bit better with that standard algorithm that we know so well from multiplication. And we'll go ahead and do that. 4 times 1 is 4. 4 times 1 is 4. 4 times 7 is 28. And, yep, 7 7 is 14. 4 4 is 8, 28. Yep. Don't see why. Yeah, 7 times 3 is 21. Let's get caught up on 3 times 9 being 27. I'm like, 27. No, but yes, indeed. 4 times 7 is 28. We're going to carry the 2. And 4 times 3 is 12. Plus 2 more is 14. And now I have 2 after the decimal here. 1 after the decimal here. 2 plus 1 is 3. Let's move that decimal over 1, 2, 3 spaces. And so we're going to end up with 14.844. All right. So let's look at this one here. And I'm trying to figure how many did I put. Boy, I got a lot of them in there. This one here, at this point, you're probably going to start. Actually, let's use the lattice method. That worked well. You're saying, what in the world is the lattice method? So 4, or 9, and 9, 4, 5. Notice I'm leaving some space between them. 2, 3, 5. So I got my number across the top. Now I'm going to go down the side with 4, 8, 2, 8. And you're like, what in the world is he doing? This is known as the lattice method. So we're going to put a line across here. And we're going to go down across here. And we're going to build this box looking thing. You're going to be like, what in the world is he doing? This looks crazy. I need a column for this number. Let's do a column for that number. Notice that for each of the numbers across the top, I'm making a column for them. And then for the numbers down along the side, I'm going to make some rows. And the reason that they call this the lattice method is that whenever we get done building this, it's going to look a bit like a lattice fence. I'm going to put diagonals through all these and try to make that, try to keep them lined up best I can. Going to get through those two. Yep, I might get through those two. Oh, I might want to just connect there to there to there. You're like, oh, well, this really seems to be taking a lot of time, Mr. T. It's actually, I kind of like it better than doing the traditional method for this. So we're going to set all this up. We're just about there, folks. Almost got it set up. Outstanding. Could have paused it while I created it, but I wanted to see wanted to let you see me creating the lattice. So how this works is we're going to do columns times rows and write the answer in the intersecting boxes, with the upper left corner being the tens place and the lower right corner being the ones place. So 9 times 4 is what, 36? So we're going to put 36. 4 times 4, 16. Notice I'm putting the tens place in the upper left and the ones place lower right. 5 times 4, 20. 2 times 4, 8. Well, there's 0 tens there, right? 3 times 4, 12. And 5 times 4, 20. 9 times 8, 72. 4 times 8, 32. And 5 times 8 is 40. 2 times 8 is 16. 3 times 8 is 24. 5 times 8 is 40. Now going down here, 9 times 2 is 18. 4 times 2 is 8. And you're probably thinking, wouldn't a calculator be a lot easier? 5 times 2 is 10. This is if you didn't have a calculator. 2 times 2 is 4. 0 tens. 2 times 3 is 6. Again, 0 tens. And 5 times 2 is 10. 9 times 8 is 72. 4 times 8 is 32. And 5 times 8 is 40. 2 times 8 is 16. 3 times 8 is 24. And 5 times 8 is 40. What I was thinking is I have 2 8s in here. I could have just copied this column and this column. I could have just copied those down. I really wouldn't have had to think of them, right? Thought of them. Next thing we do on lattice method is we start adding the diagonals going this way. These are like columns that we're going to add up. And we're just going to add those diagonally. If there's anything to carry, we're going to carry it over to the next column. So here I just have 0. 4 plus 4 is 8. 8 plus 2, I'm looking right here. 8 plus 2 is 10. 6 and 6 is 12. So that 10 plus the 12 is 22, plus the 1 is 23. Carry the 1 up to here, this next column. 1 and 4 is 5, plus 4 is 9, plus 4 more is 13, plus 1 more is 14. Carry the 1 up to here. 1, I got 2, 4, 6. 6 and 6 is 12. Put that 1 on there, that's 13. Plus 4 is 17. Plus 2 more is 19. So 9, carry that 1 up here. 1 plus 1 is 2, plus 8 is 10. 1 more makes 11. 1 more makes 12. 8 more make 20. And 3 more make 23. And 2 more make 25. Carry that 2 up along here. 2 and 2 is, or 2 plus 4 is 6. Plus 2 is 8. Plus 8 is 16. Plus 7 is 23. Carry the 2. 2 and 2 is 4. Plus 6 is 10. Plus these 2 right here make 15. Plus 1 more is 16. Carry the 1. 1 and 1 is 2. Plus 6 is 8. And plus 7 is 15. Or if you want to look at 7, why do I feel uncomfortable with this one? That's because I want to do 7. I want to do 7 plus 1 plus 1 is 9. Plus 6 is 15. There we go. And carry the 1 and 3 plus 1 is 4. Wow. Now our answer is right here, reading around this way. 4, 5, 6, 3. I'm getting these numbers just going around this way. 5, 9, 4, 3, 8, 0. Correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we have one value after the digits, or 1 digit after the decimal, 3 digits after the decimal. 3 plus 1 equals 4. So we're going to move it over 4 places. 1, 2, 3, 4 right here. So let's put our comma in for 1,000. So we end up with 456,359.438. Wow. Took a while to do that problem with Lattice. I'm pretty much suspecting that you're going to use a calculator there, just like you might use it on these here. However, let me peek. I think that's my last one there. So on this one here, I have these problems here demonstrated, and I'm not going to do the full problem. We've pretty much seen the process for it already, but I do want to show you strategies for these. So notice that we have the 7 times 7. Well, 7 times 7 is 49. You could probably do that without the calculator. So then we would take the 9.2 times 49, and I guess this one's not so bad. I could multiply it out. 9 times 2 is 18. Carry the 1. 81, 82. And that's a 2. 2 times 4, good, yep. 4 times 2 is 8, and 4 times 9 is 36. Let's add those together. 8, 10, carry the 1, 14, 15, and carry the 1 and 4. I have 1 after the decimal, so let's move the decimal over 1, so I'd end up with 450.8. On the next one here, I would probably first maybe multiply these two together and then multiply times the 9, right? And then on this last one here, I'd probably multiply the 2 and the 4 together to get 8, right? And then I would multiply these two values together. And if I did that, again, I'm going to pretend that I don't have a calculator, but I do. I would go ahead and I take that 9.51, I'm going to multiply that times 4.51. And we should have 4 digits after, we should have 4 digits after the decimal, right? Because we have 2 here and 2 here, so we know it's going to be 4. And that would be 42.8 0.901. And then if I were doing this on paper, once I had this answer from these two factors here, then I would just multiply in my head the 2 times 4 to get 8, and then multiply the 8 from there. And that I could probably do no problem. 8 times 1 is 8, 0, 8 times 9, 72, 7, and 8 times 8, 64, add 7, was it 71, right? 8 times 2 is 16, add 7 to that, 23, carry the 2, 8 times 4 is 32, plus 2 is 34. I've got 4 digits after the decimal, so 1, 2, 3, 4. So I'd be right here with 342.1208. So the important thing is to remember that in this process, let's look at some of the earlier ones. The key thing is don't worry about lining up the decimals like you do for addition and subtraction, which it looks that way here. Let's look at other problems like this one here. You don't have to line up the decimals. Just go ahead and do the multiplication and like you normally would and get the answer, right? And then consider how many decimal places you need by using this process over here, right? And then remember that there's always the lattice method. If you don't have a calculator and you have to do these really big numbers here, the lattice method, you might find that helpful as well. So those are all of my examples for IXL 7.E.3, multiplying decimals. Good luck with your activity.